Hey guys, Storm here with episode 2 of our Mr. Jump game. We'll just show you where we left off last time. We had our jump system in place, so you could jump depending on how long you hold it. And then you could also die if you run into a wall like that. Just quickly, we need to speed up the player and make gravity affect him even more. So we're going to set player speed to, we'll try 8 for now. And then on his rigid body, his gravity scale will be set to 4. Nearly working. Yep, better. And then his jumping speed will need to increase as well. So jump time, we'll try 0.3. Sort of 0.2. We'll just also increase our mid jump height to, we'll try 9 first. Yep. Perfecto. Okay. So quickly, the thing with Unity is, what's the best way I can explain this? If I create a new material quickly, and we'll just call it tiled, yeah, and we drag this onto here, and just quickly we'll set our albedo map to be just that, for instance. Don't know if that's gonna work. It's probably a bad example. Let's not do that. Let's create a new 2D object. We'll just create a new plane, for instance, yeah. And so with that plane, if we drag tiled onto the plane, when we increase the size, it stretches rather than tiling. So in Mr. Jump, they have different sizes of pretty much platforms. So platforms that are like this, yeah, platforms like this, and we don't want the image to stretch, we want the image to repeat. So there's this thing called a Planar Shader, which is where the image stays stationary, but you can stretch things. So we'll just quickly create a new shader. So we'll create a folder for shaders, and in that we'll create a new shader, and we'll call it Triplanar. And then let's open this up. So this is a shader. I'm not going to go over this too much. We'll just write and follow along, and I'll try and explain at the end of it. So we're going to change, so what this up here is basically where on a material, if I just create a new material for triplanar, we'll just say grass material, is when you go to custom here, and then it's triplanar. So we're going to call it our own, so we'll just do, we'll just type in triplanar, or we can do, yeah, triplanar will just work. These are like variables pretty much that you can set on the material here. So we need 6 variables, we'll just get rid of these. We need side, then if you just copy this line, 1, 2, 3, 4, and so that 0 should have been a close bracket, sorry. Let's just reset all those like that, and then reset all of these, deleted, and is. And then from the side you need to say it is equal to white, sorry. So if we equals white, there we go. So we're going to rename these to be, this one's going to be underscore top, this one's going to be bottom, this one's going to be side scale, this one's going to be top scale, and then this one's going to be bottom scale. And pretty much this is going to be the name that appears. So this is the variable name where you do etc. Set it out, and then what this is here is what is shown here. So you just retype these all again. So top, bottom, side scale, top scale, and bottom scale. These ones are going to be floats. So this is a variable time that goes in here. And then 2D just means like the texture. These are all equal to without the squiggly brackets. Alrighty, so subshader and then tags will be like this. So we'll do Q equals geometry, ignore projector is equal to false, render type is equal to opaque, and this is just setting certain like settings that we need. So I'm just going to delete all of that and we're going to work from here. So we want cull back, which means we have the culling on the back of the material. Z right on, CG program, all in capital letters, pragma surface surf Lambert, hashtag pragma exclude renderers flash, sampler 2D, and this is just what we have declared at the top, so side, top and bottom, and then float, side scale, top scale, bottom scale. Then we want an input struct, which is like a class, just everything's public. Float 3 world close, float 3 world normal. So these are like vector 3 sort of, which is just like positions, and yeah. Then we want a void for surface, which has an input in, and then an input an in out, surface output O. Alrighty. At the bottom in this we just want an NCG. And then our fallback would be diffuse, which is pretty much the normal material shader that everyone uses. Alright, so let's do a float 3 for our projection normal. And that will be saturated on a power of in world normal times 1.44. So now we're going to do our X side. So the side, which we float 3x is equal to text 2D of side, fracture that to in.world.pos.zy times side scale times ABS in.world.normal.x, and that should be correct. Let me just double check that. Yep, that's fine. So now we want to do our top and bottom, which is top and bottom, and that's float 3 y is equal to 0. If in.world.normal.y is greater than 0, then we want to do something else. So y is equal to our text 2D of top. Basically this is just checking if it's top, and then this one will check if it's going to be bottom. So if it's greater than 0 it's top, if it's less than 0 it's bottom. So frac for in.world.pos.zx times top scale times ABS in.world.normal.y. That should be fine, and we can pretty much just copy that. And change top to bottom. Bottom scale. And that should be fine. And then the last thing we have to do is the Z side, so side Z. And for that one we'll do float 3, float 3z is equal to text 2D for side again, fracture the in.world.pos.xy times side scale times ABS in.world.normal.z, and then we want to do o.albedo, capital A is equal to z, and then o.albedo is equal to lerp o.albedo x projection normal dot x. And if we just copy that line, albedo y and then projection normal y, and that should be all. So if we try that, exclude renderers, that should be fine. Alrighty, so if we go to this material, grass, and we change our standard to triplanar, and then we shall fix this up. So I'll open up Photoshop and I'll be back in a sec. So I'm just going to create a new 200, that's probably bad, we'll do it, 128 by 128, and I'm just going to create a texture that can be repeated, so I'll be back in a sec. Alrighty, so here's our ground texture. We'll just say dirt for now. So if we save this in a sprites folder for I'm going to say ground textures, and then this one can be dirt.png, and then just make sure we change this file type to PNG as well. Alrighty, so if we have this material here and we change our side texture to be the dirt one that we made, let me check the shader. Alrighty, sorry, that was my mistake. This has to be text 2D. I actually held shift and pressed the 2. So if we save that. And then we also need to add semicolons here and here. That should fix that. We'll check the exclude renderers part in a second. So if we just clear that for now. So with this material, as I was saying, so we go to our materials, we can select our grass material. For side, what we can do is we select our dirt. And I guess we can do that for top and bottom as well, but it won't look as what we want it to look like for now. Anyways, so for this we can drag grass onto it. Yep. And it's scaling these lines that are appearing a resultant. We'll have a look at that in a sec. Anyways, so if we scale it, you can see it's scaling correctly, like so. Okay. So what we do is if we just remove our top and bottom for now. That should be fine. Then I'll just check in here. Everything's fine in here. For our texture that we imported, let's just make sure that we change that to point. And if we change it from sprite to a texture, and wrap mode to repeat, filter mode to point, press apply. So as you zoom in, they go away. It's just a matter of how you look at it, pretty much. So if we go into our game, alrighty. So we can chuck this back to being a sprite again. I just wanted to test that. So keep it as a sprite. And then we just got to fix one more thing. So on our materials, we want it to be an unlit material as well. Just a simple fix is just to do game object light and then just do a directional light and it'll fix it for us like that. So we can have a run through and we can see everything's working as planned. Alrighty. Good. Alrighty, so the next thing that I want to do is the things that affect the player. So things that can kill the player or like special abilities. So I'm only going to focus on 2 special abilities, which is the gate that opens when you hit one of them, and the one that lets you jump again in mid-air. And then the death thing that I'll do is little spikes that can appear on the ground or the top. And then once I've done that, that's pretty much finished. We can add a few more background with what we're saying with the background in a later episode. That's not too important. You guys should probably be able to do that. But then what I'll do is I'll pause and I'll come back and I'll have made like a level, for example. And that's one other thing we have to do is the death screen, so tell you how far along you've got, and the finish. So what we'll do is we'll have like a spawn point when you make levels, you don't need to drag the basic character and you just need to make a level, put in a spawn point and then the end point, and we'll calculate the distance and we'll do it how Mr. Jump does it. So we might do that part first. 2 seconds. Alrighty, sorry. So what we want to do is create a new empty game object, and this will just be the level manager. We're going to go into our scripts. We're going to create a new folder for level. Level. Then a C# script for the level manager. So if we open that up, and then what we can do is it's going to have a public vector 3, actually no, a public transform for start point, and then a public transform for our endpoint, and then we're going to do a public vector 2 distance. We'll make that private in a second, so we can do avoid get percentage pretty much. It'll be float get percentage, and that's just going to return 0 for now, and it's going to need a vec2 position. Alrighty. So the distance, we're gonna have this execute in edit mode as well. So we void awake distance is equal to vector2 dot distance between start point dot position and then endpoint dot position. Do that, sorry. Sorry, distance has to be a float, sorry. So you can see on the level manager, if we drag our level script onto it, we'll make distance private in a second. So we're going to have a game object we'll create an empty. This will be level start. Just put that at 0, 0. And move him up and here. And then we'll just duplicate that as well for our level end. And level end will need a little sprite, which we'll make in a second. And then for our level manager, level start is there, and level end is there. So what we do is if we press play, see it will generate 27.54 is the distance between those two. We'll also set that at 0, 0. Alrighty, so the next thing that it'll need is a public game object for player. And we'll have a void finish level. And then a void end death. These need to be, that needs to be public. So what we can do is with get percentage, we'll do float td is equal to vector2 dot distance between position and endpoint dot position. And what we can do is some basic math. So what we can do is td. So what we're going to do is we're going to return td divided by distance times 100. So when player dies, we're going to have a void start level, which will just instantiate our player at start point, if we drag the main camera under basic character at start point dot position, and then quaternion dot identity, sorry. If we drag the camera under the player, yeah, it's not going to cause too big an issue. Alrighty, so for the basic character, let's apply. And so it's in our prefabs. What we can do is delete that. For our level manager, drag that on. So if we press play, you can enable that. Press play. On void start, we don't need the awake anymore. We don't need this execute in edit mode anymore. So start basically just starts our level for us, and we also just want to get a void for set distance, because the level manager will never die. So we'll just take that from there, and we'll set distance again. We'll put that up one actually, and then that should be fine for the moment. So if we press play, you see the player spawns, and all is well. Okay, so we've got that. When the player dies, for level manager, what we'll do quickly is we'll create a new tag, and we'll add one for level manager. And then we'll give that to the level manager. So on basic 2D character, we need a private level manager lm, and on start lm is equal to game object dot find, capital G, game object dot find game object with tag level manager. In level manager, we also need a don't destroy on load this game object actually, and should be good. So when he dies, or called death, create a void for die, and then called death is equal to false, true, sorry. So on is dead, what we do is if called death is equal to false, then we die. And in die we call lm.death. And then just to make sure we've got this working, is we will print we need a vector 3 position. We will print our get percentage of pos. So lm.death will just send transform.position. So we test that. component level manager. Sorry, forgot to add that. Alrighty, so if we press play and then we die, it's 87. That doesn't seem right. 2 seconds. What we'll do for debugging purposes is in our level manager for get percentage, what we'll do is we'll print the position that we get, and then we'll print the TD that we get from that. So we can also figure it out ourselves. So if we press play again, so we get 46 and 1.1. We get 24 as the distance. So if we go to our level manager, you can see 27.5. Yeah, so we need to do, what we need to do is wrap this like that, and we'll do 100 take that, if that makes sense. Yep, so we'll do 100 take that, because it's giving us the distance that we haven't done, and that's how much we've got left. So if we do 100 take that, it'll give us 12% that we've completed, because our player is at 4, and we'll just say 4 for now. So that's how it's going to calculate it. We're at 4, and then the start point was 1. So we've travelled pretty much 3 blocks. Then if you do 27 divided by 3, for instance, that's 9. It doesn't seem right off the top of my head, but it is right, don't worry about it. So 12% you can see is done. If we were to move these blocks towards the end, and then we press play, he's happily running along. You see 85%, so that's working. And rather than returning a float, we'll return an int. That would probably be the better one. As an int, like that. As an int, like that. And you also just add these brackets here and then here as well. So if we press play, yep, so 85%. Good, good. Okay, so the next thing is creating the, I'm just going to create a little drawing for a few things. So create a 128 by 128. And then basically just draw your little drawings that you want to do. So I'll be back once Alright, so here's a little triangle that we will watch out for. So let's just save this in, we'll just say level, in a folder called level. So this will just be spike. I'm going to create just a few variations of this, so 2 seconds. So like for example, this one's going to be an ice spike, just so if we have like an icy level, for example. Alrighty, so this one's going to be the one that allows him to jump again, so we'll just delete the background layer and then save this as a special jump. And now this one's going to act as the one that opens the gate. And then this one's going to act as the end of the level. So if we just save that as end of the level. Alright, so what we're going to do is we're going to jump right into this one. So level end. Actually, we just go to all our levels, these ones, select all of them, make sure they're all point Okay, so for level end, I actually want that to be end level. So select 0, 0, and 0. So if you zoom in, you can have a look at it. Yep. So that's the level end. What I want to do with that is add a component for a circle collider 2D. We're going to set radius to be 0.3, 0.4, yeah, 0.4, and it's going to be a trigger. Alrighty, and then we just want to pretty much drag these all on as well. Special jump and gate. Now these ones look a bit big for what they need to be, pretty much. So, well, in comparison to the player, yeah. So special jump has to be, we'll just set it 64 for the moment. Sorry, 128, 256. Yep. And the same with gate, 256. And then spike and eye spike will be set to just say 200. Yep. Okay. So what we're gonna need to do is chuck all of these as prefabs. So that one, that one, that one, and that one all need to come in as prefabs. So eye spike, gate, special jump, and spike. Alrighty. And what we're gonna do is we're gonna have a new script for level, and it's gonna be trigger event, and inside the trigger event we're gonna have a public enum events, and so we're gonna have spike, jump, and gate, and we'll have a public events event, we'll just say E, and then we also yeah, so if it's a gate, it's gonna need a public transform gate, pretty much, and then we'll just say void open gate is just game object dot destroy gate dot game object. Alrighty, so that works. This is only going to be used so all of these can get the trigger event. These two, spike and eye spike, can get the event for E is spike. Special jump will get the jump, and then the gate will get the gate. If you select all of them one by one and you press apply, it'll work. Now we just need to give them triggers, colliders, which would be polygon collider, make that a trigger. Same for spike, needs a polygon collider, which would be a trigger again. Gate, not gonna work. Just give it a box collider, and then just lower down the size so it's roughly, yeah, so 0.45 seems to work. And then do the same for this one. Alrighty, and then make sure it's a trigger. Same for spikes. Perfect. Okay, so now in our basic 2D character, we're just going to make sure that here is dead is equal to true, because we can die other ways as well. So this can be a public void. This is going to need a void on trigger enter 2D, and it needs a collider collision. Then we'll say player is equal to, basic 2D character player is equal to collider.get component basic 2D character if player does not equal null. Then we pretty much switch between our event. Alrighty, so we're going to switch between our E. And so we're going to do case spike, events to the spike. So we're going to do something, break, then case events dot jump break. After doing something, and then case events dot gate do something and then break. So spike is just going to tell player dot die. Jump is just going to mean player dot cans. We'll add in here a public void cans change special jump, and then can special jump is equal to not can special jump. So we'll just do change special jump, and then gate is just going to open gate. Alrighty, so that's that done. Yeah, make this a collider 2D. So if we press play, yep, so the player dies. I like how it has a slowdown effect, so we can jump, and good. If we jump into the special jump, it seems as though he dies there. Let's just move the special jump up, the gate up. Alrighty. Change these tags to we'll add a tag, we'll just add a wall, right? And we'll just set it to wall like that pretty much. so that when the player is checking if he dies or not, we'll add up here a raycast hit, 2D hit. Ooh. Six. Wrong spot for it. We put it there, and we'll do if hit dot game up. If hit dot transform dot tag is equal to wall. So if it's equal to wall, then we can kill him. This sounds brutal, but yeah. So just make sure you do that for all the ones that he can run into. Q6. Alright, so we're gonna have to redo this. Raycast hit is going to be equal to that. We're gonna get rid of this and this. Move that down. And we also need to do if hit.collider does not equal null. And then we remove the out hit like that. Just get rid of that bracket there. Alright, so we've pressed play. We should be able to jump, right? And we die there. If we jump up, if we jump and hit that, there we go. So just make sure that for every ground object that you make, you pretty much give it the wall tag, pretty much. It's usually the best way to go about it. Alrighty. So what we're going to do is we're going to do a bracket around this. Then we're going to do an OR, and then we're going to copy that. And then we're going to also do can special jump. I'm just going to check if this works. Yeah. So that works. So if we just remove that, here we do if can special jump, then can special jump is equal to false. Just so we don't continuously do it. That was a fail. Yeah, so you can see that we can double jump, and if we just move that along, we can pretty much keep doing it. Yeah, perfect. So the next thing I want to do is on the trigger event, we're going to add one more for base events dot level end rank. So we're going to do level manager lm, and lm is equal to this. Then we're going to do lm dot finish dot finish level. And so this gets the trigger event. It gets the level end. What I'm going to do is I'm going to put this over here. I'm going to rotate this. And what I'm going to do is for the gate, we're going to give it the prototype, the gate that we wanted to remove. So if we press play now, yep, perfect. And then what we can do is we can just do a spawn player, and then spawn player is equal to that as transform. And then we can just do spawn player dot get component, and we'll do basic 2D character, then we'll just do die. Done. What we'll do is for our player prefab, we'll give him a tag of player. Then we'll do spawn player is equal to game object, find game object with tag player dot transform. We can make this private again. Boom. Alrighty. So where we'd come from here is with our finish level, we'd have a list up here. So like a using system.collections.generic list of all the levels that we have, and then we just go on to the next level, and at the final level we'll bring the finish screen, and we're going to do a death screen, but that'll be for the next episode. I've been Storm, and I'll